Hello, everybody. Can you hear me?
Yes, we can hear you. Good afternoon.
Well, I would say good afternoon from Thailand and good morning in some countries. Probably good evening for other country in South America. I would like to introduce myself first of all. My name is Noparat Bamroongrugsa. My education background is that my bachelor degree in botany from Chulalongkorn University, Thailand. And after that, I went to Australia for my diploma and master degree in science in agriculture from the University of New England, Australia. And lastly, I had my doctoral degree in crop science from North Carolina State University, USA. Well, after my degree, I went back to Thailand. And I started to work with mangrove up to now, about 35 years. So today, I will share my experience because some of you here may be familiar with mangrove, and some of you may not be familiar. If some of you have a good knowledge or good background in mangrove, please share with me. After my 35 years working on mangrove, actually in my doctoral degree, I work on nitrogen fixation in peanut. But when I went back to Thailand, my senior friend asked me to work on mangrove because during that time, very few specialists working on mangrove in Thailand, and I turned my direction to mangrove. For my session, I think that we can ask questions in between, because some of you may forget what you have understood and what to ask question. You can share your knowledge or whatever during my presentation. Okay, for the first slide, the topic of my session is sustainable basin management for mangroves in the advent of climate change. Actually, I have two sessions. First session of part one today. The story or topic is what is mangrove, or what are mangroves? I hope you have heard about mangrove, most of you. Mangrove is a woody tree or shrub that live along the coastline within the tropic or subtropic latitude. For those friends who are in other countries, say northern latitude, actually we can find mangrove in other countries as well, like in Australia. What the degree that part 38 degrees Celsius? Oh no, 38 degree latitude. We still find some mangrove over there. So from our participants from many countries like Iraq, Iran, or Azerbaijan, with that country are close to Azerbaijan, close to Caspian Sea, and like Iraq, Iran, that Persian Gulf. I hope you have some mangrove over there, even though it is not the real location for mangrove, like in the tropic or subtropic. Yeah. Where this mangrove, you can see mangrove. Mangrove normally, I will tell you the detail later on. I will show you the picture of mangrove that normally grown in the tropic or over area. There are many species of mangrove, as you know that. Some of them we call true mangrove. Some of them are associated mangrove. So later on I will tell you what the meaning of true mangrove or associated mangrove. What is mangrove or what are mangroves? A mangrove is a shrub or tree that grows in the coastal salines or brackish water. The question is that, can it grow in the fresh water? Yes. From my study, my research, they grow quite well too, the fresh water. But why they grow in the coastal saline or brackish water? So we will talk later on. Two, mangrove occur worldwide in the tropics and subtropics, and even some temperate coastal area, mainly between latitudes 30 degrees north and 30 degrees south. Mangrove are sun-tolerant tree, also called halophyte. Halophyte means tolerant to salt, and are adapted to live in the harsh coastal condition. They contain a complex sun filtration system. We will talk later on, and a complex root system to cope with the sun water immersion and wave action. When what I said before for mangrove that normally grow well in the tropic and subtropic latitude. I went to Japan. Yes, the mangrove grow quite well in Okinawa and some island over there. In Australia, in New Zealand, they grow quite okay for one species we call Abyssinia in the Queensland area and also in New Zealand. I hope that even in Azerbaijan, close to the Caspian Sea, you can see mangrove as well. I have not been there, but I hope you can see some of them. Mangrove are sun-tolerant tree, also called halophyte, that was said before. Yeah. Mangrove tree and shrub that grow in briny water along coastline in tropical and subtropical regions worldwide play many important roles in supporting coast and coastal communities and economics around the world. Among them, providing coastal protection, filtering water. What do you mean by filtering water? You know that normally when the water comes from the land, from river to the sea, root of mangrove can absorb some you call it a nutrient or like a nitrogen, phosphorus, potassium, for mangrove as well. So it cleans up the water and supporting the livelihoods of the people who live in the around them. Yet, despite their importance, more than a quarter of the world mangrove forests have been lost over the past several decades to aquaculture. Like in Thailand, after the Second World War, we lost about half of the mangrove forest. And the real estate development, that why they clear the mangrove forest for this activity. Local harvesting and other pressures. Okay. Mangroves are one of the most productive ecosystem, vital ecosystem on Earth. They perform a variety of useful ecological, biophysical, and socio-economic function, and are the sort of multiple of benefit to coastal pollution. And this is only introduction. So after that, I will show you a PowerPoint picture, to enable you to understand the story. Okay, this is mangrove in Thailand. Normally, mangrove grow in zonation. Some species grow very close to the coastline, and other species may grow a little bit far away. What factor control this? There are several factors. You see that? Tidal factor, slope of the area, muddy condition, and whatever. Okay. This is the roots of mangrove. There are different kinds of roots of mangrove. This is the root of Rhizophora. We call the one species that grow close to the coastline. Rhizophora, they produce a prop root to support the stem and also absorb nutrient, absorb water from the substrate. Okay, you can see this Rhizophora root. This somebody called red mangrove. You know, red mangrove, white mangrove, and black mangrove at the back. For red mangrove, close to the water. Okay, this is Rhizophora. You can see the root is supporting and arresting, and also it's home. Is a home for marine animal, particularly for the baby fish or juvenile animals living around here, to be away from the predator and to protect themselves. You see that? They grow normally on the mudflat. However, for mangrove, you can see some mangrove growing on the sandy soil or even on the rock. It's incredible. Yeah. Number of fish species use mangrove as nursery, as I mentioned before. Young fish are vulnerable to predators on the coral reef or in the deep sea. To sustain population number, many species take to the safety of the mangrove to spawn, where larger predators are unable to follow them. So I heard that about 70% of small marine animals use root of mangrove at home, and after that they will move to the outside sea after they're growing up. You see the food chain and energy flow in the mangrove forest. This is very important map for the importance of mangrove. As for the food chain, the food web, it's pretty complicated. You see, this is mangrove tree. The leaf form, fully leaf. After that, what happened? Decomposition occurs. It attacked by microorganisms and many marine animals. Some of them feed on direct feed, because direct feed on the leaf. And some of them, after the leaf digested and eat by small organism and move to the higher creature, higher animal. You know that normally we eat fish, we eat crab, we eat lobster, whatever. Where the meat come from? Sometimes we ask ourselves where the meat come from. Normally fish eat what? Algae is small animal, a small microorganism or whatever. You know, where the primary source come from? Like a cow or cattle grazing on the grass. Eventually, the grass that eaten by cow is converted to protein, to carbohydrate, to fatty acid, to sugar or whatever. Similarly, for mangrove, this is the primary productivity. They call the primary production by plant. This mangrove is the primary productivity. After it decomposes, it's eaten by several other creature. Yeah. Yeah. You look at that. So the primary productivity mangrove, it chain bird eating the other smaller animal, crab eating what. This why mangrove like similar to, I would say, similar to the grasses that eaten by cattle. But this in the sea or in the saline water. Because the grass cannot grow in this area. In addition to this, also seagrass or fungi, that they are the sort of energy for this thing. But mangrove play a big role in this. So I will tell you later how important for carbon accumulation of mangrove. Generally, mangrove grow in the waterlogged soils that are commonly anaerobic. Okay, why the land plant cannot or very difficult to grow in an anaerobic condition? Redox potential of mangrove sediments vary considerably depending on the frequency and duration of tidal inundation, drain lakes, sediments, organic matter content, and the availability of electron acceptors such as nitrate, phosphoric, and manganese or whatever. Normally, generally, mangrove grow in the waterlogged soil. Generally, when it grow in the waterlogged soil, it means that without oxygen underneath, because the oxygen very difficult to move into the water to the root. Therefore, if the water lack of oxygen, the root cannot show the mechanism of respiration because no oxygen. However, mangrove can adapt themselves or adapt itself by having special root system. We call erecting root or supporting root, that underwater lock soil.
Sorry, Dr. Noparat, please.
Yes.
I have.
Hello?
Yes, please. I have a question.
Yes.
You mentioned that it is filtered water.
Say again, please.
Mangrove is filtered water in the slide, the first one, which is the yellow one.
Yes. And this one?
Yes. No,
yeah.
no, not that one. Other one, the previous one, the previous.
Not
yes,
this one?
That's one.
Yes.
Yes, that's one. No, the other one.
No, not this. Okay.
No. Sorry, the white one. It is. You said that it's filtered water. Yes, this is one. Please.
This one.
No. The forward, please.
This
forward.
one. This
forward.
one.
Yes, that's one. That's one.
Yeah.
You mentioned that it is filtering water.
Yes.
What meaning of filtering? Did you mean it's convert to the fresh water, or it's filtering from a sediment?
Normally, like filtering water is mean that polluted water from the ground, or mixing in the sea water. Mangrove can absorb minerals or nutrients from that water, like it clean up the water by absorbing that polluted water. Then we use the word filtering water. You understand what I mean?
Did you mean it's absorbed only the salt to stay the water fresh?
Well, normally I will tell you later on how mangrove absorb salt water And filtering, it means that, it's trying to clean up the water by absorbing only water, but try to get it off, or try to, it absorbs nutrients like a phosphorus, nitrogen, and in form of nitrate to use by mangrove itself. So water become clean up. So we use the word filtering water. That you clear that?
Okay, thank you very much.
Yeah.
Thank you.
If the water comes from the land, okay, or polluted water in the sea, mangrove can clean it by absorbing that contain material or polluted material in the water, and water become clean. So we use the word filtering. Okay. So we move ahead.
Okay, thank you, doctor.
You went up. Yeah. This is a food chain and energy flow. This is very important. Mangrove acts similarly to the like a kitten. Grass eats grass, and this would say is the grasses of marine animal. Some of them they eat directly, some crab, by most of them after decomposition, decomposed by algae, by bacteria, and decomposed and eaten by small organism and bigger animal, even to the crab. So this is very important. This is the key point of mangrove, actually. How important mangrove, and most people not understand much about the use of mangrove or the benefit of mangrove. Okay. Normally I said before, what mangrove grow in the waterlogged soil. So you can see this a trip by my student to the area of mangrove growing. You see there is the slope of land there. Some mangrove grow in the area or in the edge of the water, close to the water. But other mangrove grow down there. It had a zonation of mangrove. Yeah. Some species grow here. Some species grow farther. Okay. This factor of flooding will determine not only how often, but also to what depth mangrove species are inundated. The frequency of flooding. According to McNee, salinity is also one of the factors that influence the establishment and zonation of mangrove. Variation of salinity occur in relation to the level of the substrate and the frequency of inundation by seawater, as well as the pattern of inflow of fresh water from the lands. Drainage is another factor in the survival of the mangrove, since some species require well-drained soil, whereas the other can flourish in poorly drained, waterlogged soil. This factor is related to the property of soil, slope of the surface, and the presence of the local creeks. So this is only some basic knowledge. I think this knowledge may be useful for you to apply later on, because sometimes basic knowledge is quite important. We don't know how to go, what direction should go. If we have basic knowledge enough, we can apply to many points. Mangrove forests are vital, healthy coastal ecosystem, providing nutrients for the marine environment and support immense variety of sea life in intricate food webs or in complicated food web, as well as reducing coastal flood storm vulnerability. Human pressure on coastal ecosystem is often high, with land competition for aquaculture, agriculture, infrastructure, and tourism. The consequent conversion of mangrove area to other use over the past decade has been alarming. Also, vulnerability and threats to the mangrove from climate change are continuing and increasing. Okay, this is generally some statement. You can see there that the fishermen use it boat, for fishing because plenty of marine animals around here, but they live in mangrove area. Okay, in some area, they use the mangrove as a place for tourism. You see canoeing, along the creeks or canyon, growing mangrove there. Well, this is the habitat, of muddy soil where mangrove grow. You can see many kind of animals there. And in this area, when the leaf or branch of mangrove fall into the mud area and flood with water, what happened? It's hardly to decay, very hard to decay. And it become deposit, root, branch, or wood deposited there, under there, deeper and deeper. Therefore, the soil under mangrove forest is a good place or good sink for carbon, because carbon accumulate there. Some said about 4 to 5 times higher than land plants. This is muddy there. We can dig up the soil and check the carbon accumulation. And at the same time, because of carbon and many kind of nutrients there, animal like a shrimp or lobster or whatever, not a crab living there. Mangrove protect coastline from tsunami, from hurricane, from typhoon. As you know very well that in Thailand in 2004 we had a tsunami. Anyway, in India, in many countries, Sri Lanka, India, and many countries there, mangrove save a lot of life. However, depend on the density or depth of how thick the mangrove forest there. If mangrove is thick enough, I did my survey during after tsunami. Many places were destroyed by tsunami, and the place where the mangrove was over there, thick forest. It's good enough to protect life and protect home of the people. Yeah, so this is quite important. If any places, any area that confront to the sea without mangrove and all, it's quite sensitive to tsunami or to wave or typhoon. So try to grow mangrove, restore mangroves better. Mangrove forests stabilize coastline and prevent erosion. That normally stabilize like that. Mangrove absorb pollution and protect coral reef pollution. That's what we discussed before. Absorb pollution. Okay, this some mangrove. This picture I took before. You see this coastline. This is the root of some mangrove. It become like a sea wall, to protect the area. You see that this root strong enough to protect the wave in that area. But I don't think it can help much for tsunami, because tsunami wave is very strong. But this root, normal wave or wind, you can see there. In some species, like exocaria, okay, you can see after wave action, strong wave, we have to put stone, throw the stone there. But for this tree, no need to put stone. It's not strong enough to help to protect the shore. When this is the dense of mangrove, there, root system. When after tsunami, this my picture I took in 2004. After tsunami, I went there and checked the effect of tsunami. You see there, with the mangrove, some were destroyed, and some still left behind. And the home or people living behind the mangrove, they were safe, you know. But in front, for the front line of mangrove, they were destroyed. But only few still left behind, left over there. But most of them destroyed by tsunami. Mangrove plant require a number of physiological adaptation to overcome the problem of low environmental oxygen level, high salinity, and frequent tidal flooding. This is quite important. Each species had its own solution to this problem. This may be the primary reason why on some shorelines, mangrove tree species show distinct zonation. See there? This species, this Sonoratia, it developed root. This we call like a nematophore. We call nematophore. Normally nematophore underwater. Normally it's short of a lack of oxygen. So all living tissue have to respire. It needs oxygen. When they need oxygen, they have to do something by growing the root for air resting, for air to get oxygen. And in each of the nematophore there are plenty of hole, we call it ledicent, the hole for oxygen to move in, okay? Underneath there are fibrous roots for absorbing water and nutrients. But this root for breathing, different for breathing, for allow oxygen to move in. Other species, as when Avicennia, the same thing. They have some kind of nematophore that we call pensin root, this nematophore. And then some of them grow up to human 150 centimeter high in some location. Morphological and physiological adaptation and environment where the water is filled with high concentration of the soil. Water levels are constantly changing, and in oxygen-deprived sediment would certainly exclude most plants. However, mangrove thrive in these conditions. They have evolved certain morphological and physiological responses, which allow them to avoid the pitfalls of this hard condition. Okay, important to the coastal ecosystem that he inhabited. Physically, they serve as the buffer between the marine and terrestrial community and protect shoreline from the damaging wind, wave, and flood that we mentioned some of them before. Mangrove thicket improve water quality by filtering pollutants. That's what they said. Filtering pollutant and trapping sediment from the land, and they reduce coastal erosion. Ecologically, they provide habitat for a diverse array of terrestrial organisms and many species of coastal and offshore fish and chain fish rely exclusively on mangrove as their breeding, spawning, and hatching ground. Because of their high salt tolerance, mangroves are often among the first species to colonize mud and sand bank flushed by seawater. But an increase in the coastal development and on the land use led to a decline in global population. Several species are listed as a vulnerable or endangered species. Mangrove are this important. You have to know that this quite important point. Mangrove are facultative halophytes, which means that salt water is not a physical requirement for growth. Salt water is not a requirement for growth. They need fresh water. Most can grow well in fresh water, but mangrove community are not usually found in strict freshwater environment. Why? Mangrove needs fresh water, but it grows well and adapt itself well in the salt water. Normally, when they absorb salt water, the salty water, normally the mangrove grow well around 3 to 27 parts per thousand, part per thousand water of salt water, while the ocean water is about 30 part per thousand ppt. But mangrove can grow well. Grow well in the area where salt water about 3 to 27. But normally, that mostly higher than that, some species can grow. It hurt that I know that in some area up to 30 or 70 part per thousand. Some species can grow too, but very few. Okay? We can seal it out. Okay? When you can grow mangrove at home, actually, you can grow mangrove at your home, at your garden. You see that? Because mangrove needs fresh water. But salt water still okay with me, that's what mangrove say. Because they have mechanism to secrete or to exclude salt by my own mechanism. Sometimes in the morning you can see salt crystal on the leaf. They're secreted by some species like Abyssinia. Why other species they can kick off the salt, reverse absorption, reverse osmosis, not allow salt to move in. Some species, or some of them they move in and they keep in the vacuole, add the salt in the vacuole, not for use. But when the salt seeks crystal in the leaf and the leaf fall down, so salt become down. However, fresh water is good, okay. You can grow mangrove in fresh water, but you can try now. However, when from my experimentation, I try to water with salt water when this tree is still young or in the seedling periods. Salt water normally mainly damage my young plant. So at the beginning, I grow in nursery, I use fresh water. When the tree grow up, I hope that it developed a mechanism by having salt gland in some species. But at the younger state, most of my experimentation, if I water with salt water, they die easily. I become dry out. So salt water can come later on. That's from my experimentation too, Normally, mangrove grow in salinity range from 0 to 90 ppt, part per thousand. It can, you can see 0 to 90 part per thousand. In Australia, there is one species, or we call Abyssinia. They grow in the high salinity. But in higher salinity, it stuns the growth. It will grow less, or like a small shrub. Salinity higher, it grow, but not grow well. Rest mangrove are found where the soil salinity range 60 to 65 part per thousand. Black and white mangrove have black and white mangrove have been recorded in soil salinity greater than 90 ppt, 90 part per thousand. In restrict bay and flat water, salinity often ranges over 40 ppt. For most species of plant, this condition would inhibit growth. On the other hand, mangrove have evolved physiological response to utilize this specific condition to outcompete other species. They are adapted to the low oxygen condition that set for over the log mud, but more likely to thrive in the upper half of the intertidal zone. Of the recognized 100 mangrove species, only about 55 species in 20 genera from 16 families constitute the true mangrove. True mangrove, you can see the character, all character, what is suit to the condition, but other species may not suitable or adapt to the environment we call associated species. Okay. The red mangrove normally close to the shoreline. Survive in the most inundated area. Crop is sent above the water level with the stem of crop roots and then absorb air through ledicent. What I said before, it is bark. Yes, this for mangrove to protect strong wave or wind or tsunami or hurricane. See, and the slope there, the storm come like this. It is a mangrove. It has a strong enough root system. It has a lot at the back area. Yes, there is some. You can see some species even grow on a rock condition. Not necessarily to grow in the muddy all the time. Because from my experiment, I used to grow mangrove on the rock, in one island. The Sophora, they grow okay too. Yeah. However, they have to have enough flooding, at least twice a day, because of flooding carry with the nutrient to supply to the tree. This in Singapore. In Singapore, they want to protect the shoreline by trying to establish the Sophora on the rock like that. That in Singapore. I don't know how successful. The black mangrove at the back, Abyssinia juvenalis, live on higher ground and develop many species root-like structure called pneumatophore, which stick up out of the soil like straw for breathing. Red mangrove a close soil by having significant impermeable root. The red mangrove a close soil by having impermeable root. Select by selection, acting as an ultrafiltration mechanism to exclude sodium salt from the rest of the plant. Analysis of water inside mangrove has shown 90 to 97% of salt has been excluded at the root. So it means even grow very well in the salt water. But mangrove do not or doesn't use salt. It had a mechanism to get it off the salt. Why the land plant? They lack or short of that mechanism. There's no mechanism to do that. My students used to ask me, can I grow mangrove in the paddy field? That they asked my question. Can I grow in my garden or in paddy field? What do you think? Can you grow mangrove in your paddy field or in your garden? Anybody can answer me? Can you grow mangrove in your paddy field or rice field? No answer at the moment. Yes, you can grow. You can grow even in the rice field, in fresh water. However, because of competition occur between land plant and mangrove plant. Mangrove plant, normally mangrove is a sun-loving plant. Sun-loving. Mangrove can be shaded out by land plant and not enough sunlight. Therefore, competition less than land plant. It grow, but after that, they disappear. If other land plant, even some climber, that block the sun or shading effect, mangrove can disappear. Mangrove community are typically normally zone, it's a zone, with the zonation depending on a variety of interacting factors, namely physical, chemical, and biological, which determine whether a species will survive in a given environment. The interplay and balance of these factors determine whether one or several species become established. Some factors that appear to determine the survival of individual species, such as frequency of flooding, which is dependent on the tidal pattern and on the height of the shore above mean sea level. You go there. It typically zone, depend on the sea level. From mean sea level and low sea level, high sea level, high, medium, low, medium, high. You see this area, they flood at least twice a day. One species become flood by on medium, high, okay, this one different. One this species grow, but flood by normal high tide, this area, normal high tide. But the rest of them, flood by spring or exceptional high tide, or rarely flood. Instead of flooding, therefore species will grow here. Some species that flood twice a day or once a day become the species. This is called zonation of mangrove. The species suitable for some area. So when you grow mangrove, when you restore the mangrove, you have to know what species should grow and where, what place to put what species of mangrove. If you grow a wrong species at the wrong place, they die. This is quite important for selection of species to grow. Yes, yeah. Medium low time, mean high springtime. See, because this area, when it flood, salt will accumulate there. So the land plant difficult to grow with the salty soil condition. This area, salty, by mangrove had a mechanism to remove the salt. But for this one, in a way, this becomes zonation of mangrove. As some of you call this red mangrove, black mangrove, white mangrove, or whatever, It's there. This red mangrove there, high tide, when the tide will come to this area. Yes, that just somebody called a stem root. Because this root can come from the main stem or come from branch. Is at the substrate, the fallen leaf there, and underneath there you see plenty of animal living there. This tree, the root system, they try to develop the root that exposed to oxygen also, but the root just above the soil, not a nematophore, not everything root like a nematophore or pension root, but these root are like a knee root or whatever, or something like that, similar. The root, my student collect the organism under the canopy of mangrove. This the root system. Roots can go that far. You have to know that normally for mangrove, there is no taproot mangrove. Without taproot, because underneath no oxygen. Therefore, they produce a long cable root. And that cable root, they produce secondary, tertiary root from that root. And some they germinate or spring up at a nematophore from the cable root. Little root of Avicennia, I think, this one. Because you can see the pension root down there. When this is the Avicennia, they secreted salt and become crystal on the leaf. It take the salt water and secrete the salt, and they use fresh water that you can see the crystal there on the leaf. Red mangrove can also store salt in the vacuole. White and gray mangrove can secrete salt directly. They have two salt glands at each leaf base. Because of the limited fresh water available in salty intertidal soil, mangrove leaf with more water they are lost through their leaves. Because it, some leaf of some species, it had a succulent leaf. It means the leaf that feed off a lot of water, so they dilute the salt. So it absorbs water and keep water, store water in the leaf. So many species of mangrove, it had succulent leaf, a leaf that fill up with water. Rhizophora stylosa can grow even in the saline water, and the salt level in its root is regulated within a certain threshold value through filtration. Filtration. Get it off, not allow the sun to move into the tissue. Mangrove have involved a special mechanism to help their offspring survive. What do you mean? Mangrove seeds are buoyant and are therefore suited to water dispersion. Mangrove seed, you see this species, see that? When it for Rhizophora? Rhizophora, when the flower, it produces seed. The seed germinates while the seed still attached to the parent plant, attached to the mother plant. It germinates, the seed is there, and germinate, and become the seedling. It grows on the mother plant. Why? Because it can drop to the muddy soil. It depart. When it drop, it take root. Root come out. See? Need the seed there. Fruit or seed or whatever. After that, germination occur. They grow while the seed still attached to the mother plant. This is we call vivipary or viviparous condition. Go there. There. So when you restore mangrove, you have to put the right end of the, we call proper cool. This one proper cool. It's called proper cool in the soil. Some of them, when they grow mangrove, they put this end to the soil. It's when they die. So we have to put this in. When they drop, it drops from the mother plant, drop down to the mud, and this grow. However, if the water floods there, the water can take away. Wave action, tide can move this to other places away. It will take a month to the place from this propagule, because propagule. This way, this person of mangrove seed by current, by tide, if they move to the right place, right location, it germinates like that and become. That's why somebody called this a walking tree. Walking, it can walk because of the root system, and also when this propagule drop to the bottom of the stem, it grow the other one, and the new tree, new generation occur, and walking like that. Somebody called walking tree. You see there, this root system, root system of the Rhizophora, and also the nursery for marine animal. In 2018, the Global Mangrove Watch Initiative released a new global baseline with estimate the total mangrove forest area of the world as of 2010 at 137,600 square kilometers, spanning 118 countries and territory. A 22 study on loss and gain of tidal wetland estimate 3,700 square kilometers. Net decrease in global mangrove extend from 1999 to 2019, which was only partially offset by gain of 1,800 square kilometers. Mangrove loss continue due to the human activity, with the global annual deforestation different rate estimate at 0.16%. That deforestation, and per country rate at high as 0.70%. Degradation is inequality of remaining mangrove is also an important concern. Like in Thailand, 40, 50 years ago, we lost about 50% of mangrove at the moment. But however, we try to restore. But what is slowly restoration? The most extensive mangrove area is found in Asia, followed by Africa and North and Central America. Asia had a large extent of mangrove, approximately 6 million hectares, and 5 of 10 countries with the largest extent of mangrove worldwide are found in this region. Indonesia is a main mangrove forest, is the largest one in Southeast Asia, or probably in the world at the moment. Yeah. See there, that mangrove area in the world, even in Australia, in New Zealand, more in Indonesia, some in Okinawa, Japan, even in you see this Persian Gulf, see Iraq, Iraq here, or Iran, this Caspian Sea, that Azerbaijan, I think probably you can see some there. I don't know, but can you see? Oh yes, yeah, there are some there. and of course in South America, in Africa, Nigeria, Liberia, or Ivory Coast, Cote d'Ivoire, different plenty of mangrove, even in eastern part. Mangrove. India, okay. But the other zone, normally mangrove is killed by frozen. When temperature getting too low, young seedling always die. You know, this is why in temperate zone it's difficult to find mangrove mainly because of temperature, controlled by temperature. However, this area temperature is too high, low, this high altitude, high longitude too, but it's close to the sea because it's probably seawater temperature is buffer enough for mangrove to grow there. Why up there, very difficult, but close to the sea there, even latitude there, still you can find mangrove. The most substantial loss of the world mangrove cover is due to their conversion to other land use, such as urban area expansion, industrial development, aquaculture, agriculture development, and charcoal making. In Thailand, we have charcoal making quite a lot, because they say the charcoal for mangrove, when you make charcoal, you can eat what do you call beef or barbecue with good smell, So people prefer using charcoal from mangrove quite a lot now, good to sell in the market, but now people try to not accept this kind of charcoal from mangrove because they clear the mangrove quite a lot. Among this, chim aquaculture has been the single biggest driver of mangrove destruction, particularly in Southeast Asia. Since 1970, aquaculture development had decimated vast area of mangrove forest in the Gulf of Thailand, Vietnam, Java, and Kalimantan, Indonesia, and the Philippines. Every year, thousands of tons of chim from aquaculture farms from Southeast Asia are exported to Western markets. This in Southeast Asia. Mangrove in Burma, mangrove still okay. Burma, Thailand, in the Western coast, Eastern coast, very little, few, not many in Thailand, but more in the Western coast. People ask why in the eastern part, the mangrove in this area very short, not tall, not as tall as the Western. One thing probably because of, I don't know, nutrients or the water in Thailand, flooding water, can affect too. This in Cambodia, Vietnam there, a lot in Malaysia, some Indonesia, Kalimantan, in Australia, okay, in Carpentaria Bay, in the northern part of Australia, quite a lot too, quite a lot there, northern part. The capacity of mangrove seagrass is so much to sequester carbon dioxide from the atmosphere is becoming increasingly recognized at international level. Of all the biological carbon, also termed as green carbon, capture in the world, over half of 50%, 55% is captured by mangrove, seagrass, and sun marshes. another marine living organism, which are also known more specifically as blue carbon. See, green carbon, biological carbon. Mangrove play an active role in this. Through photosynthesis, mangrove absorb carbon from the atmosphere and store in all their parts, just like any terrestrial plants. But unlike terrestrial plant, mangrove store carbon in the sediment as well. That's important. Why the terrestrial mangrove cannot do the same? They store in the sediment because of muddy condition. Less carbon means low global warming. A hectare of mangrove forest can absorb around 20 tons of carbon each year. 1 hectare. 20 tons of carbon each year. See there? But some those who have a little background are not familiar with photosynthesis. There's a plant. CO2 absorbed by photosynthesis, light, and release oxygen, and got sugar. And sugar become carbohydrate and become wood, and suberin, lignin, or whatever, become a wood. Cellulose come from the sugar and converts to this material. And root absorb water, and when it die, some tree, some species, what do you call the weight of underground parts is similar or more than above ground. What when did it die? It died, accumulate there in the ground from oxygen to reduce CO2 in the air. We know that climate change is driven by greenhouse gas, mainly carbon dioxide. The more forests that can capture and use carbon dioxide for photosynthesis, the faster this greenhouse gas will be removed from the atmosphere, which benefits society as a whole. And compared to other types of forests, mangrove have very high rate of carbon capture. Most mangrove carbon is found in the forest below ground biomass, mainly the root and in the sediment. This a little good point. They store or keep underground the carbon kept underground below ground biomass. See light. Photophosphorylation, CO2, ATP become sugar. So at the same time, in photosynthesis process, it needs the same energy, for respiration as well. Therefore, oxygen is required. Even the mangrove underwater or in the muddy condition, it had to develop something to get oxygen for respiration. Mangrove forests can fight climate change. We all know that plant photosynthesis using up carbon dioxide and emitting oxygen into the atmosphere in order to grow. Yet, mangrove forests are especially adapt to storing carbon in soil and their root, that's what I mentioned before. Due to their ability to absorb carbon, mangrove forests are known as carbon sink. Mangrove forests are known as carbon sink or carbon-rich biomes. By storing excess carbon, they can reduce global warming, and there is less carbon dioxide trapped in the atmosphere. According to the research, 14% of constant carbon sequestration is thanks to mangrove forest. Yeah. Different species growing. Mangrove, saltmud, and seagrass form much of the Earth's blue carbon sink. This coastal vegetation sequesters carbon far more effective, up to 100 times faster, and more permanently than terrestrial forests. Further studies have shown that per hectare, mangrove forests store up to 5 times more carbon than most other tropical forests around the world. This ability of mangrove and other coastal vegetation to store such large amount of carbon is, in part, due to the deep organic rich soil in which they thrive. Therefore, cutting down mangrove means releasing large amount of carbon into the atmosphere. So we have to preserve them if possible, preserve or restore in some area. Alongside the living biomass, mangrove soil are carbon rich, sequestering and storing carbon at a great depth. While mangrove cover a significantly smaller area compared to tropical forest, they are incredibly efficient. Okay. See that the carbon. When the branch drop, the root or leaf or whatever, to the ground, it becomes deposit there. And loss of mangrove area. Mangrove habitat have declined in terms of biological diversity, forest structure, and economic value due to excessive harvesting of the most valuable tree. This had caused a shift in the forest composition towards smaller trees and the secondary growth when larger trees were removed. This is our area in southern Thailand. It used to be mangrove area before. And after that, it converted to shrimp pond. You see there, large area of mangrove converted to shrimp pond. But now, this activity has been less because the law try to prevent cleaning the mangrove to convert to the prawn farm. Sometimes when we travel along the coastline, we can see the mangrove, already good mangrove, but at the back, what happened? No mangrove. When we fly, after that we try to restore most abundant shrimp pond. We try to restore by growing mangrove. In some area, they grow very well with Rhizophora, grow in there. Okay, this is some area in Thailand. You can see former mangrove natural forest. They clear for shrimp pond. When we try to restore this land, it's not easily successful. Many percent, fail. 20% may fail because of we grow the wrong place, wrong species. If we grow on the mud flat here, put the wrong species in, they won't grow. When you grow the mangrove, you have to know, you have to see indicator plant, at least some species grow there. If one species can grow there, you can follow by the same species to grow, because the other species, is not suited to the place, So try to grow the right species or the right place, right location. I mean, to restore mangrove this year in Thailand. When you try to cut mangrove, one species, this pioneer species come. Okay, let this new species grow first. After the other species will follow later on. If we clear all species here, and grow the not suitable species, they may die easily. So let the pioneer species grow first, and it become what do you call many we got mangrove society instead of pure stand, because it passed through the succession state. This species come first, and the other species will follow. But for man-made or restoration by man, they put that species there, here, without what you call development or developing of the soil or the habitat there down there. So they die easily. Let the nature do it first, and we follow later on. It becomes a mixture of tree or mangrove there. Estimates suggest a range of between 150 million to 1 million tons of carbon dioxide that emitted annually due to the destruction of mangrove forests globally. Thus, at the global scale, coastal wetland destruction could account for 1 to 3% of the industrial emission. A number that is on the rise as more and more coastal wetlands are destroyed every year around the world. Thus, mangrove forests offer a unique and highly efficient approach to the climate change mitigation and adaptation. Carbon store, and they can sequester up to 3 to 4 times, 3 to 4 more carbon on an area basis than the traditional counterparts, and remain stable for a long geological time scale if undisturbed. Mangrove loss can equally lead to carbon being emitted back to the atmosphere. Between 2000 and 2012, 2% global mangrove carbon was lost through deforestation, equivalent to 317 million tons of carbon dioxide emission. Yes, this comparison on biomass and estimate carbon content above the ground. Tropical rainforest biomass above ground 444 tons per hectare. Mangrove forest in Indonesia, it varies from 169 to 436, as compared to other temperate evergreen broadleaf forest, this subboreal forest, this crop field, okay, in terms of biomass. And estimate carbon content, this tropical rainforest and in mangrove, okay. Then below ground quite a lot, not only above ground. Mangrove forest in Irimote Island in Japan, that 100,000 carbon, 270. Tropical rainforest in Malaysia, 72. 72 plus 8. Mangrove forest in Panapi Island and Micronesia, 1,000 total carbon. This southwest coast Thailand, 500 mangrove forest, Taiwan, Taiwan, okay. So it's mean that even below ground or above ground, mangrove forest may have higher carbon than tropical rainforest. See there, the root system. In terms of biomass, underground or below ground, this heavy, compared up there. Leaf is not so heavy, but the thickness or heavy weight of this leaf, the weight of these roots quite high, So it means carbon in here. See there, in some species, root, it can protect the shoreline and also accumulate carbon. We used to survey the seedling of mangrove after 4-year planting, the root system then. It did the sophora down there. With Abyssinia later on when the flood come here, it developed everything root. If no flooding, we would not see everything root. If flooding, yes, it developed. Mangrove are shallow rooted. The root being concentrated mainly in the top 50 to 100 centimeters of soil and seldom penetrating to the depth beyond 2 meters. Because down there, it had less oxygen, anaerobic condition, so it penetrates not that deep. Water and nutrients are absorbed by a dense mat of fibrous roots that usually originate from the underground cable roots or smaller secondary roots in close proximity to the aerial breathing roots. Thus, mangrove must have adaptation if under stress, especially aerial root of them. Many studies show that they have morphological, physiological, and metabolic adaptation. Okay. See there, that the dense match of mangrove root and home of several marine animal, fish, crab. In Thailand, the mangrove area of Gulf of Thailand have subtly decreased and deteriorated in quality when compared with the Andaman coast. Over 20-year period, the mangrove area of Gulf of Thailand coast decreased, that they record in right, 6.25 right per hectare, and it decreased a lot. It lost 3.4, the rate 3.4% per year in Thailand. The main factor leading to that I said before is habitat loss caused by conversion of progressive degradation of the forest, water pollution, and withdrawal. When offsite activity can lead to the mangrove degradation through sedimentation and change in the water flow and water quality, especially salinity change and change into pollution. Recognition of the environmental, social, and economic impacts associated with the decline and degradation of mangrove are now being addressed through legislative management, conversion, and rehabilitation efforts aimed at mitigating the negative impact of development on mangrove ecosystem. Here in Thailand, we have legislation on that. According to Sanisuk, in Thailand, we have 71 species of tree and shrub have been recorded from the mangrove forest in the Gulf of Thailand. This species include 77 species of what have been classified as true mangrove, or species that are bound to the saline of brackish water, and 44 species classified as mangrove associated with a species of the littoral vegetation that regularly occur in the back or more landward zone of the mangrove forest. The most common mangrove species is Rhizophora spicculata. Why other common species belong to family Rubinaceae, Rhizophораceae, and Sonoratiaceae? Yes, in Thailand we have showed you before the Andaman coast, plenty of mangrove down there. But in the Gulf of Thailand, destroyed quite a lot now. In Bangkok area, a lot of mangrove have been clear with eastern part. This in Thailand substantially decreased and deteriorate in quality when compared with Andaman coast over 20-year period that I told before, as I said before. Okay. Yeah. Yes, because of human activity there, we lost a lot of mangroves. But now we try to restore them. Yes, in the past, this picture took about 10 years ago in the area where shrimp farming activity, they convert the land to shrimp farm. By restoring, we try to restore growing rice species and some nipa palm in some area, and grow some species there. This we check and we study after growth for some time. We check the structure of mangrove and then what species invaded by new species or not. Yes, that I told you before, the roots of one exocarya colosha, one species of mangrove, you see, like a rock. There's a rock there, but here no rock. You can use a root and a rock, to protect the shoreline. Yes, this is a Nipa Futakan. It is a basin mangrove. So tomorrow I will talk about basin mangrove, like a lake mangrove or flooded basin mangrove that far away from the shoreline, far away from the cotton sea, okay, cotton shoreline. This mangrove, it grow in pretty, even 5 kilometers, 10 kilometers away from the shoreline in the basin. I will and talk tomorrow. Some of this species in the lagoon, even the lagoon. So Songkla Lake, because Songkla Lake, that actually is lagoon. We have some mangrove there. So we talk tomorrow. Yeah. It's some species that protect the shoreline. Okay, mangrove roots. The roots but trace of one species. And tourists can go there, some species there. Okay, now we show you video because they gave me 2 hours. 2 hours, but now the Thai already passed half an hour left. So we'll show you video about the mangrove in Thailand. Investing in the coastal ecosystem, okay? So to have a trip to coastal ecosystem with these 2 video, 2 to 3 video I have, so finished in 2 hours. Anyway, anybody have a question there? Please, you can raise your question and we can discuss. We have about 20 minutes or half an hour, something like that left. You see the video. So we ask a question first. Anybody had a question? No question? I don't know. You understand my presentation or not? Talk very fast. Hello? Can you hear? I don't know. I'm really here now. Now we go to video then. What the first one? Video. Cầu
มัยแต่แรกนี่ก็การทำมาหากินของชาวบ้านก็สร้างบุกันสร้างบุสร้างอ้วนลอยสร้างเรือเขียดแล้วก็สร้างเฮ้นั่นเครื่องมือที่ว่านัดเลววันสมัยแต่แรกกันสร้างเฮ้กันตะกุงขึ้นมานี่ไปทอดขึ้นเราคุมได้ถึงเดือนอาหารแกเราไปทำขึ้นเดียวแต่ว่าเราคุมได้ถึงเดือนกินชายได้เดือนแต่ว่าราคามันถูกราคากุ้งก็ไม่ก่อนโล5 บาท
Yes, they said in the past there were plenty of marine animals, but now they decline quite a lot, and it's very difficult to catch fish compared to the early days.
รวมในคลองมารุยตรงนี้แล้วก็ชุมชนชาวหินดาวคลองมารุยถาย้อยถาไซถึงคลองทรายอันนั้นก็มาหากินพอในทรายคลองตรงนี้มันมีความอุดมสมบูรณ์เกี่ยวกับหอยกระหมากปูกระหมากปลากระหมากถึงจำพวกที่อาหารไปอยู่ในป่าก็เป็นหอยดีโกงหอยเข็มหอยจุ๊บแจงหอยกันแม้ว่าตาลิงสะแม่ลิงพังกาก็เยอะแต่กว่าปลาชาลินก็มาว่านี่ครับผมไปเจอก็มาวางเบ็ดเจอปลาเกาะมักเลย
You see, the chairman of the
มีพี่น้องมากิน
conservation team to conserve the mangrove. He said that in the past fertility was very high, but now they decline quite a lot in terms of fertility of the water of marine animals. They say in the past when when you are mining area, after tin mining, and they clear on most of the mangrove forest in that area, and sorry to for that kind of destruction. And seawater becomes turbid. I mean, turbidity of water very high after tin mining. Therefore, a lot of villagers they move out from the village, move to other places, and migrated to other country too. After tin mining. The villagers they try to form a group to protect the mangrove and restore.
หลังจากปีซ่ามาหรือที่ว่าทางช่องท่าหมู่บ้านได้รวมฟื้นฟูรวมกันซึ่งผลประโยชน์ตรงนั้นโดยการฟื้นฟูตอนแรกก็ชาวบ้านไม่ค่อยเห็นด้วยในการปลูกป่า
At first, the villagers not very much agree with restoration
ความเปลี่ยนแปลงที่เกิดขึ้น
because they don't know much about the use or benefit of mangrove.
ปลาก็เข้ามาให้ฟัง
But after that,
หลังจากการไป
when there was
ต่างจังหวัดก็ได้
some kind of migration
กุ้งว่าหมูป่ากับผืน
of marine animal into the place.
สร้างกิจกรรมในตัวนั้น
They understood
กันเอง
the importance of mangrove
นำต่างๆก็ได้รวมกัน คือเห็นผลประโยชน์เลย
and work together.
ว่าการปลูกป่าตรงนี้ทำให้มีทรัพยากรเพิ่มขึ้น
Restoration
หน่ว
can
ยงานต่างๆเลย
result in the higher productivity
เราก็ได้
of the sea.
พระนางเจ้าเคยตรัสไว้ว่าปลูกป่าได้มากกว่าต้นไม้ผมก็ได้ข้าวๆตรงนั้นประมาณ5 คนผู้ใหญ่สั้นด้วยกันกับผู้ใหญ่สวัสดีตอนนั้น คือสมเด็จพระนางเจ้าได้ตรัสไว้วันนั้นว่าปลูกป่าได้มากกว่าต้นไม้ผมก็คิดว่าได้เห็นชัดเจนเลย คือหลังจากปลูกป่าต้นไม้ขึ้นมาแล้วมีห้อยขึ้นอยู่บนต้นไม้สัตว์น้ำเล็กๆเข้ามาใช้มาวางเคยแล้วก็ชาวบ้านก็ความเป็นอยู่ก็ดีขึ้นเมื่อก่อนบ้านบางพัดนั้นบ้านมุงจากทั้งหมดแต่มาตอนหลังนั้นถ้าจะเห็นตรงนี้ก็คือสร้างเป็นมาตรฐานเลยบ้านบาง
After restoration of mangrove,
ยังมี
the standard living of the villager
ก็มี
are better.
ได้หมากได้โครงอย่างเช่นว่าที่กุ้งปลาก็ได้หมากพอไปวางปลาดักใส่วันก็รู้สึกว่าเป็นรอยตัวปลาใส่ปลาเก๋านะเดี๋ยวก็ส่วนหนึ่งของคลองบางเตยทำให้ผมได้มีฐานะมาถึงทุกวันนี้ได้ขึ้นมาอยู่บ้านก็มาจากคลองบางเตยส่วนหนึ่งได้เลี้ยงปลาเก๋าไปทำจับปูจับปลาอยู่ในคลองนั้น
ตอนนี้เมื่อมีพี่น้องมากินหมากทรัพยากรทุกอย่างมันก็รวมรวยร่อลงซึ่งผมคิดว่าถ้าเรามีการตั้งเครือข่ายรวมกันแต่ว่าบางเตยพี่น้องบางเตยพี่น้องมูซ่าข้าวเจ้าบางพัดท่าไรแล้วเราก็มาตั้งกลุ่มกันแล้วรวมหัวกันเพื่อจะทำให้คลองของเรามีมันอุดมสมบูรณ์มากขึ้นถึงตอนนี้มันก็สมบูรณ์อยู่แล้วแต่เราต้องการให้มันมีมากขึ้นกว่านี้ผมคิดว่าเป็นแนวทางที่แก้ไขที่ยั่งยืนมากผมคิดว่า
With the villager
มีการปล่อย
in the area, they form the committee to protect the forest.
ทำให้กว้างในระดับตำบล
Community involvement,
ในตำบลได้เข้า
community involvement in the project
ซึ่งจิตสำนึกตรงนี้มี
to bring up the awareness
ชุมชนนั้นรู้จักรักทรัพยากร
to love the nature, to love the resource. Okay. Well, anybody want to discuss or have any question? Because we have about 10 minutes left. Any question? If no, thank you very much anyway. See you tomorrow. Tomorrow at the same time. I will talk about Basin Mangrove tomorrow. Okay, bye-bye.